Alright, now let's look at a second such problem. The question on the top of the page. Alright, the production of soda cans at a bottling plant is supposed to have an average of 12 ounces with a standard deviation of 3 ounces. 0.3 ounces, rather. Yesterday, an average of 11.95 ounces was obtained from a random sample of 50 cans. Today, an average of 12.1 ounces was obtained from a sample of 50 cans. What is the probability of getting a change this large or larger if there is no real change in the average, true average? Alright, some students are probably thinking, what happens if I, as in the last problem, did not call my first sample 1, the one that I called 1, that is the before 1. Let's say I called after 1 and before 2. Right? Well, nothing changes. The whole diagram of the normal distribution gets flipped around, the mirror image. So let's show you that here. All right, let's sort of do the after the today's sample. Let's call that 1, and yesterday's sample, let's call it 2. Okay. And some students like to do that when they have two samples like this. They like to put the larger average first. It just makes their intuition just a trifle bit easier. But once you've decided which sample is 1 and which is 2, don't ever think about changing it unless you just start from scratch. Alright, so let's call today 1 and yesterday 2. Okay, we had 50 cans in each sample. Alright, it's like a quality control thing. Today's sample average 12.2 ounces. So, sorry, 12.1 ounce. Alright, this number right here. Yesterday's average 11.95. Okay. Alright, remember we need some population data. We need mu1 minus mu2. We'll need the standard deviation sigma 1 and, oops, wrong place for that 2, sigma 2. Alright, what's the probability of getting a change this larger or larger? Well, that means that our limit x bar 1 minus x bar 2, 12.1 minus 11.95, if I can do that quickly in my head, that's 0.15. So that's the change, the difference, but this is the change. What's the probability of getting a change this large or larger? Alright. If there is no real change in the average, so it's just like the previous problem, no real change, no true change in the true averages, so that mu1, today's average minus yesterday's average, is 0. And where do we get our standard deviations from? Alright, we're not told that the true standard deviations is anything other than what it's supposed to be. So we will say that the true standard deviations are 0.3 for both today and yesterday. So the question is, what is the probability of getting a change? No. What is the probability of... Yes, it does say that. A change. Notice that what it doesn't say, alright, what this does not say is what is the probability of getting an increase this large or larger, or it does not say what is the probability of getting a decrease this large or larger. This has been an increase, but the question says change. Change is irrelevant of being up or down. Okay. So in this case, it's the absolute value greater than, and I'll show you on the diagram to make it clearer, 0.15 ounces, where the mean of the distribution, of the normal distribution of sample differences is 0, and the standard deviation sigma sub x bar 1 minus x bar 2 needs to be calculated. Alright, the diagram, before we all get concerned about this, too concerned about this, Alright, so we have a normal distribution of sample differences. We have a mean of this distribution of 0. And in this case, we're talking about a change. Oops, that'll be positive 0.15 up here, of course. But down here we'll have negative 0.15. What's the probability of getting a change this large or larger? That means a change from 11.95 could go up 0.15 ounces or could go down 0.15 ounces. What's the probability of getting a change this large or larger is the area in those two tails. Alright, once you've understood that, then when we go to the z, we'll find these two limits which are symmetrical. Not by my diagram, but anyway, symmetrical. Whatever this positive value will be is the same as what the negative value is. Okay, and we will go from there. So back to our story, or calculations. We need standard deviation sigma sub x bar 1 minus x bar 2 first. Alright, so square root of sigma 1 squared on n1, and I'll not forget my square root sign, plus sigma 2 squared on n2. Alright, so sigma 1 was 0.3 squared divided by a sample size of 50, and sigma 2 is the same in this case. Again, it does not have to be the case that these are all the same. Alright, so standard deviation, square root of 0.3 squared divided by 50 plus 0.3 squared divided by 50. Alright, the value is 0.06 exactly. Okay. And so to go to our z values, let's put that down here somewhere. The z will be the limit x bar 1 minus x bar 2 minus the mean of the distribution, normal distribution, mu1 minus mu2 divided by the standard deviation sigma sub x bar 1 minus x bar 2. The limit, say the first one, positive 0.15, the upper limit, minus the mean of 0 divided by the standard deviation of 0.06. Alright, it's 1.15 divided by 0.06 is 2.5, or 2.50 if you like, and the same thing will occur on the lower end. Alright, and you can do that calculation too. For instance, there'll be negative 0.15 minus 0 divided by 0.06, and that'll be a negative 2.50. Okay, two places. So on our z distribution, we want to find the probability of getting a z greater than 2.5, or, so it's a, remember way back from probability theory, probability of getting, a z less than negative 2.5. Alright, so the or means the addition rule, so we add, and etc. These two are both the same, so all we have to do is 2 times the probability of getting a z in the upper tail, 2.50, and that to get in the tail again, just like all the previous problems for a little while, has been a half minus the value from the table from 0 to 2.5. Alright, let me find my normal table. So 0 to 2.5. Alright, it's 0.4938. So that'll be 2 times 0.00 blah 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 62, I believe. And that'll be again, I'll do this in my head, 0, 1, 1.24, right? It's about 1.25%. So probability of getting a change that large or larger, right, at 0.15 ounces change or larger at any one day is about 1.24%, and that's unlikely given the other specs that they gave us. Okay.